Hello, my name is Colin. I am a lead business development manager at Juniper Networks. I am in the security business unit. Actually, to be technical, I'm in the core technologies unit, which includes security. And that's a very different title than I had when I originally recorded this video and then had to throw it in the bin because I forgot a video transition and did about 8 minutes of voiceover with this view and no context through the view where I'm in the corner and you can actually see the desktop. All of my efforts to hack that video together into something usable failed, so I am re-recording this, the 11th and for now final video in my Apstra and Eve NG series. Updated, I should say, Apstra and Eve NG. This is 4.2.1. I understand because this is a day 2 operational video, there might be some folks that are watching this video first. And if that is the case, I would encourage you to go watch video 1 and 2. I'm not trying to ape for links here and views. I just go into a little bit more depth around what Apstra is as a platform, the intent model that it uses, how it's multi-vendor, which is very important because of the way that it creates an abstraction layer with hardware. It's very differentiated. What I don't want you to do is just view this video, see the dashboard, not understand what's going on under the hood. All of our companies, when I say our, the Ciscos and the Aristas and the Junipers and all the others who have these types of software platforms, we hire UI, UX experts to do the design. So they have a tendency to look same or similar. By way of example, I already brought up a tab that has cloud vision. You can see, right? Circles, green, good, red, bad. Circles, green, good, red, bad. If you just look at this and don't understand why Apstra is different, it can look and feel like other solutions. And it's just really important to understand that it's not, it essentially eliminates the issues caused by unintended consequences. Unintended, you make a change over here to break something over there you weren't expecting. That doesn't happen anymore with Apstra. And it's important to understand why and how. The operational scenarios that I'm going to be going through today are going to simulate issues. I'm not going to be going through building additional subnets or tenants. You can use the earlier videos in this series to essentially deploy the things that you want to deploy, because even though I was doing those things in a day 1 context, the workflows are no different. If you wanted to create a new VRF, a routing instance, or new virtual networks, subnets, that just go through those workflows again. I wanted to use today to showcase how you would troubleshoot problems and the unique ways that an intent-based platform like Apstra can present information to help speed that process along. The scenario we're going to be going through today is the loss of a link. And I created a scenario that's a little bit more real world within the documentation. And I've also used this when I've done presentations with customers where you've had a link failure, you've contacted remote hands, and you've asked them to replace transceivers. In our lab, I've already actually taken some of the steps you'll find in the documentation. I have disabled the original link, or I should say suspended, to use the language of Eve. That would be gig 002 on leaf 1 and gig 001 on spine 2. And I've added this other link. If I were presenting this to a customer, I would not talk about these specific links because I would tease out what the issue is from here first. This is an instructional video, so I want you to know what our starting state is at the moment. What has happened, essentially, if you want to follow the narrative, is that remote hands, they fixed the problem by adding a new link between the 2 switches. Whoops. It could have been that they took the old link out and they just repatched it wrong. Who knows? Who cares? What we have is the anomalies that we want to troubleshoot with. Where I'm starting from, if you're following along with the documentation, is slide 8. We can see that we've got 28 service anomalies. We'll click on DCA. That'll take us to the dashboard. There are three main sections here. We have deployment status, and because we're not dealing with deployment status today, we're dealing with issues. We're not focusing on that. We're focusing on anomalies, and we're focusing on node status. All right, quick refresher on intent. We define an intent in Apstra, which is essentially a network design that is converted into the code required to execute that intent in a production environment on the hardware we're using, whether it's Juniper or otherwise. As long as it's supported, we know the configuration elements that go. So we built a fabric, we added some tenant stuff, a routing instance, a couple subnets. When we build that intent, that's the source of truth. It's always being simulated in real time on the Apstra server, and then it's being continuously validated against the production deployment. When we see an anomaly, what we're really seeing is based on these categories that we have predefined, we're seeing instances where the intent staged to the simulated fabric that is running on the Apstra server does not match the production, the active configuration. Those anomalies are deviations from the intent. Down here, node status is just a different way of representing the same information. These circles that you see will get larger depending on the number of anomalies. We can see that here if we mouse over that we've got 9 in this larger circle on leaf 1, and we've got 2 on these other, 1 in this tiny circle. This allows us to start to correlate the impact of anomalies and point us in the direction of where the issue might exist. In a real-world scenario, you are going to start by troubleshooting these, cabling and interface outright. Even though you have these other issues, Apstra is not going to only show you the cabling, it's going to show you everything that's being impacted. So we have route anomalies, we have BGP, obviously peers have gone down because we've dropped a link. You're going to start at layer 2. You might be wondering what the difference between cabling and interface is. Cabling is if you have layer 2 adjacency. That's just going to be like, is LDP working? Do I have link negotiation up? If we click into this, you'll see that my expected, my intent, and the validation, the actual, I have a null value here. You might have been expecting up and down. We see that if we look at interfaces. That's where we actually see that up and down message. In both cases, though, we can see the impact. We know what the interface is supposed to be. We have the physical and the logical, IFD and IFL respectively, if you're using Juniper terminology. Let's jump back here. So let's click on this route. We see now that we get the route verification view. There are other anomalies, obviously, on this switch. We're kind of hitting the center of that X and Y on the node status chart. The difference here is if we were to go click on the route anomaly here, we'll see that we see where all of them are. Cool thing here that I'll do a little bit of setup for. When I'm introducing the product, sometimes I'll walk folks through operational scenarios. The one I like to do with routing would be to present a technical audience member with a scenario where they're missing a route from a route table on a switch, and ask them what steps they would take to troubleshoot. And once they get a couple steps in, I will stop them and I'll ask them how they would know that a route was missing from a route table on a switch to begin with. We don't get tickets like that. Tickets don't have that information. Tickets say that there's a service impact and you have to troubleshoot to that point. Because we're dealing with a intent platform with Apstra and we're continuously validating that intent, we know if a switch is missing a route. Beyond that, we know if a switch is missing a next hop from a route that is present, which is what we see here, where we actually have a route, but we know that one of the next hops we should see for that route in the route table on that switch isn't there. And that's where we get this partial message. If you've ever done troubleshooting routes, you know just how darned cool it is to have access to that information. All right, so let's click back to our dashboard, and now let's click on spine 2, the word right here, versus clicking on the bubble. We'll click on spine 2, and now we'll see all the anomalies that are on spine 2. This is just a different way to access that kind of information. Another way that we can do this is we can click on active. we get to this screen here, and we will see the impact and the anomalies that we're seeing that are creating that impact. And of course, in this case, it's a fabric. Every single switch that's in the fabric is going to be impacted because the route table on every single switch is going to be impacted in one way or another. We can narrow down our blast radius. If we click on cabling here, then we will only see the switches that are impacted by a cabling anomaly. You can see now we're drilling down. We're down to spine 2 and we're down to server rack. Can't really see the name here, but trust me, then I say it is server rack leaf 1 here. Let's click on spine 2. And now we can see a graphical representation of the problem. And that is this, there is a link that is down. One other thing that I'll show you, just because it's directly relevant to the failure that we're creating here, is root cause analysis. In the future, there will be additional RCA elements that'll go here. Right now, the RCA that we have is connectivity. So this is really just more of a technology showcase for future enablement. I expect this to get really interesting as we continue with our AI ops integration. It's cool that we get to focus on the I think what really matters with our AI ops, that is application performance. There are other vendors that have solutions with AI integration, and presuming that some of them have now gotten past just the LLM, I can misspell a query and still get it the answer that I'm looking for. The application for AI ops, if you're not using intent, is to speed up troubleshooting of problems that Apstra doesn't have in the first place. You can't break your fabric by pushing a configuration from Apstra. So we don't need AI to fix that problem. We need AI to fix the next level problem, which is optimizing application performance, which is going to take us actually out of the fabric. We already have flow integration, which unfortunately I couldn't get to before I switched jobs here. It's very cool and compelling. It means we're still one step or multiple steps ahead. So what I've done here is I've enabled root cause analysis. I've clicked on the connectivity RCA, and it brings me to this screen. I can view essentially, here's where the issue exists, and I can click on tabular view, and it will actually give me what I would consider to be the real RCA. And that is that you've got it linked down, you've got LLDP missing. All of these things point directly at there being a link issue that we already know exists. And it tells you actually how many anomalies are being generated based on this one issue, right? What's the problem? Disconnected spine. Great. So there's two ways to fix this. You can fix the problem by patching the correct ports, or you can fix the problem by updating the intent to use that link. Normally, if we weren't using a controller, the way you would do that is simply copy the configuration on those switches for that interface to the new interface that's being used. If we go to staged physical links and then click this, Apstra will use LLDP to see that that link actually exists. If I go to update cabling map, now this isn't committing the change, as I'm just going to revert what I did. You'll see that it understands that these devices are interconnected on GE00 on either side. I can click update and then I can commit that. It will update the intent, and without me doing anything else, everything will go green. It'll say, all right, great. We're using that link now. This is a very cool thing that I hope everybody that ever gets introduced in Apstra gets to see. That ability for the tool not just to operate your fabric, but to also to sense when it can almost self-repair. Like, all right, well, I'll use the links that are available, because ultimately I'm trying to abstract from you all the complexity. I just need these switches connected together. Your intent is to have a fabric. Your intent isn't that I specifically need these ports. I mean, it could be, but generally speaking, the intent is I need a fabric so that I can run overlay. And then the overlay abstraction is simply, I need a VLAN on a switch port in this routing instance on that switch and that rack connected to that host, right? Every DC change is some combination of those things. Like I said, I'm not going to update my intent. Rather, I am going to fix the problem. I'll delete this link, delete, and I will resume this link. And I will pause for a minute to let all of the anomalies clear.
Hey, Homer, the section you're supposed to be monitoring is on fire.
For our next trick, we're going to log into Spine 1 and configure an NTP server. This is manual configuration, non-fabric impacting, mind you, but manual configuration nonetheless. Configure set system NTP server 172.27. Geez, really like that 8 key apparently. 171.253. Put in whatever you like here, it doesn't matter. mgmt_junos, very important if we're actually configuring a legitimate NTP server. We're going to use the out-of-band interface. And we'll commit and quit that. Great. Jump back over here. And expect to see that config deviation pop up here in a moment. As I've mentioned in previous videos, this happens faster with physical hardware. Virtualization adds a little bit of drift. We'll see this just a moment here. There it is. We've already seen what this looks like by clicking through the anomaly here. So let's follow a different workflow. We'll click on Active, and then Anomalies. And here we can see that we have an anomaly on Spine 1. We know what it is, Config. We'll click on this, and then we'll click on Config. Here we get a side-by-side. Again, on the left, what we should see, and on the right, what we are seeing. We could use these buttons down here to navigate to where those diffs are. Click on Next Diff, and we'll see that we have added NTP configuration here highlighted in green. If it was removed, it would be highlighted in red. If we had config over here that got deleted, we would see that represented over here by hierarchy config highlighted in red. We have some options here. We can accept the changes, which essentially folds that into the intent, or we could apply the full configuration, which essentially would wipe that additive config out. There might be a tendency to want to click accept changes here. This would only be for that specific switch. If you're trying to do NTP configuration or logging or something else, you probably want to do this through a configlet, not on a switch by switch basis. So let's do that instead. I'm going to click apply full config. I'll say confirm. Without a commit, this will revert the configuration. I haven't updated my intent. There's nothing to commit. So applying the full config is a one-click resolution. That will take a minute, and actually it'll take a few seconds, and we are now in a fixed state. Let's say you want to apply this configuration the correct way. From anywhere, really, you will want to go to your design and click on Configlets. Good time to pause and remind folks that there is actually one way you can break Apstra, and that is to push a configlet that disrupts the operations. Be very careful with configlets. Be very careful to limit the config that you might apply through a configlet to things that don't impact the fabric. Things under the system hierarchy are usually pretty safe. A lot of times what I see folks doing here is putting in place logging config, NTP, obviously, things like that. Maybe you've got a management filter that you want to apply. You could do that through here as well. Just be very careful with this. And when in doubt, open a case with JTAC, have them review your configuration, make sure it's not going to blow things to pieces. From this configlet screen, we want to create a configlet. We'll call ours NTP. Junos is where you match up with the operating system you're going to apply this to. You can do this in either hierarchical or set delete. The example that I am going to use is going to be set delete. In my documentation, I include examples of both. The set command is just a little easier to type out for the sake of the video. Set system, NTP server. This is exactly the same configuration that I put in 253 to the CLI in the last section. Great, we do that and we say create, done. That's all it is. We apply this by going to our DCA blueprint. Staged, we use this catalog tab here and the Configlet subtab. Every blueprint that you want to use a Configlet in will have to have that Configlet imported. In this case, I'm going to be importing the NTP Configlet. And I can apply this here based on devices. If I had tags, I could do it based on those tags. I could do it based on names, host names. There's a lot of flexibility for customization here. In this case, spine and leaf, it's NTP, whatever. Do import configlet. And what this does is it takes that command and it folds it into the intent. And then I would commit this blueprint for that configuration to take. Let's do that. We'll say commit. And once that is completed, we should see it show system. Configuration, system, NTP. There it is. Applied. I'm not going to leave that there, so I'm going to actually use Time Voyager and revert. Roll that back. Wait for this to say, and you can see I've removed the configlet here. We'll go ahead and commit that. That'll pull it out. And if I want to modify or delete that configlet for whatever reason, it does need to be pulled out of the catalog here. So I can go to staged catalog. This is, oh, it's already gone. Great. Oh, because I undid the last bit. If I wanted to do it and I didn't roll back, you would just come in here, you'd click it and you'd delete it. And then you'd be able to go into here and remove it as well if you like to. And I'm going to do that because I want this clean for the next time I might want to walk somebody through. Go back to here. We've looked at a couple operational scenarios around errors and issues. Let's just say you want to thumb through the telemetry information that's coming off of the fabric. There's obviously a lot of cool, innovative ways that you can interact with Apstra when you're troubleshooting, but there might be a need for you to track certain resources down. If we're looking for live information, we're going to go to this Active tab and we'll go to Query. Clicking on this will show us all of the nodes that are connected to our fabric. You can see these are all leaves, and what do we have over here? Max. We can search for any of these. This is BMS 1. We know that because it has AE1 connected to it. If you want to use the search function, we could actually highlight this, and just assume that you have so many devices in here that just viewing them on one page isn't practical. Think of any data center of any scale or size. You're not going to be able to fit all the connected hosts onto one screen. We can do the same thing with ARP information. It's a bit of a longer list, but we don't even need to scroll through it. We've been doing enough testing in this video series that we know exactly what the IP addresses are of our connected hosts. Once again, we'll get similar information as we saw when we were querying Mac, as you would expect. Jumping back to active, we're going to look at a pretty cool end-to-end flow representation. I don't want to call it quite a diagram, but it will help us see link utilization. From here, we can just click on one of our connected BMS servers. We can use this headroom to view a pipe diagram. And this isn't all that interesting because it's just showing flow between the BMS server and the rack it's connected to. What we're going to do is change this neighbor to EXTRTR1, which will give us the flow representation through the entire fabric. This isn't super interesting in my environment because I'm not running any traffic generators. but it can be pretty cool in a production environment. You can mouse over any of these pipes between nodes and get access to the interface statistics and some other information immediately, which is really nice. Let's go back to active, physical. I'm just clicking on these to sort of reset the view. And we want to view specific telemetry. If I click on, in this case, I'll just select spine 1 and then click on the name over here. Once I'm here, I can click on telemetry. This will look very similar to some of the views we saw when we were doing some of our troubleshooting. The point of being here is just the opportunity to click through and see what these different tabs actually provide. We can see the entire configuration that's been rendered. We can look at the interface state. It is representing all the interfaces, so only the ones that are in the fabric will be represented here. We see that we have this unintended. Notice that these are paired off. We've got our physical and then our logical. Physical, logical. You can see that over here with a 5 and a 5.0. The ones we're really interested in are the ones that are part of the intent. You'll see that these ones that are unintended are here because we know that they're physical ports on the device based on the interface map and device profiles, but are not used by the fabric. Same, we can see what MAC addresses happen to be learned locally. This is a spine, so obviously that's going to be empty. And just kind of go through and see the information. This was really useful to me because there was a point where somebody had asked me during a product introduction, all right, everything's working, but how do I go see the BGP peers? Where do I go to actually view what's happening in real time? And that's the answer. You would go to the active part of the blueprint. You would select the device that you wanted to view. See, still got some filters here that I want to get away from. See, I'm still under spine 1. So if I went to DCA, active, and then any of these, I'll actually click on spine here. And I believe that if it shows me the name, over here I can click on it and get to telemetry and click through that information. And that brings us to the last section of our last video. Bittersweet, but an important section nonetheless. We are going to walk through hardware replacement. There's a couple steps here. The first is adding a new managed device. If you have the luxury of doing so, it's always best to have that device that you'll be swapping in already onboarded and managed. So we'll do that here. Then we're going to undeploy the existing device that we're going to be swapping out from the intent. And we'll add the new one into that intent and apply the configuration to it. We'll be working on DCA spine 2. Step 1 will be to add a new node. I am going to spare you watching all of this. If you want to see the process for onboarding a new vJUNOS or VEX switch, then I think it's video 2 in this series will take you through that. I'm going to pause, and when I come back, this switch will be on and it will be managed. Again, you're not going to see all those steps. There's some custom configuration that I need to put on. I need to make sure it has an IP address. That is all in the documentation, but if you want to see the actual workflow, go back to, I think it is the second video where I show you how to onboard your devices and get them managed. That will be the state that we will be in when I return. Right. Powered up. I note this in the documentation. I'm going to leave this link blue so it stands out. We can differentiate it from this spine as we move things around. I have this new device that is now managed. You'll note that it is not assigned to a blueprint. It will be replacing this device right here. All right, spine 1. Oh, I'm sorry. Spine 2. We need to remove the existing spine from our blueprint. We'll do this from staged under physical topology, so we're already where we need to be. We're in our build. We need to go over here to that screen we went to where we assign nodes. Find spine 2, and we'll undeploy it. Just click on that, click Update Assignments. And then we commit. What we're doing is we're updating the intent to tell it that this device no longer exists in the intent. We want to do it in this order so we don't generate unnecessary anomalies. The fabric can operate with just one spine. You don't want to leave it in that state. By updating the intent, we now make that role available for the new node that we will be deploying. My instructions say delete the original spine 2 lab. For the sake of what I'm doing, I'm just going to remove the links and move them because I want to revert this back to its original state. So I'm not going to actually delete this from the environment. Right now it is undeployed. I will delete these links and add them to the new spine one at a time. Pretty this up a little bit, move that over, move this into that position, right back to where we were a moment ago. Staged, physical topology, clicking on this. Removing that assignment and then changing it to 17. Putting it into a deploy state and updating the assignment. We'll commit that. And we'll give it a minute to bring everything up and online. Because this is additive, there's a little bit of a period of time while the configuration is applied, links come up. And in the meantime, I will talk about what it means to actually delete the old device. So we can see spine 2, the original here. You see it's in that OSS ready state and it's not assigned to any blueprint. If the device was deleted, if this was deleted, we could just delete the off-box agent. And there is a workflow you want to use for this. Step 1 is to delete the agent, and then step 2 is to delete the device. If the agent still has connectivity to the device, the trash can you see here will be grayed out. The appropriate workflow is to click this button, which will uninstall the off-box agent. Once that off-box agent is uninstalled, you can then delete the device. If the device is unreachable, then this will not be grayed out. And if you know it's not reachable and this is still grayed out, just click this check. That'll refresh, attempt to connect to that off-box agent. You want to do it in this order: agent first, device second. I'm not going to do that here because I want to swap everything back to where it was, but I do want you to be familiar with the workflow, and it is laid out in my documentation. We're going to give this a minute. It looks like those anomalies are still clearing here. So while those are clearing back to me, this is the end of the series. I want to thank you so much for watching through. It's an enormous amount of work on my side, but I know from the first series and the other videos that I've done that people do find these to be useful, and that is why I do them. I do have a secondary benefit that I realize through the recording of these videos, and that is that I get to learn more about how these things work. I think teach the teacher kind of thing. I understand things better when I build documentation and when I try to help others to understand and learn how to operate these types of solutions. Thank you for giving me that forum. Thank you for your feedback. Thank you for your likes. This isn't a part of my job. It never has been. It's just something that I like to do. And the engagement that I get from you watching this is what makes it worth it to me. See, everything's up. Goodbye for now. I don't know what the next series is going to be. I'm really deep in security strategy at the moment. It will almost certainly be a security video, but I don't know when. Hopefully it's a data center related one. My intention is to continue recording videos as I find the time, even as my position and role changes. Again, it helps me so much, and then you interact with me, and that helps me kind of grow and learn as well. I hope you have a great rest of your day. I hope you've enjoyed this series. Take care until we see each other again.